Projection of a vector. In this module, you will learn to find the projection of a vector on a line. Consider a vector A making an angle theta with the directed line L. The orthogonal projection of vector A onto line L is obtained by dropping a perpendicular line from the terminal point of vector A to line L. Vector P represents the projection vector of vector A onto line L. Look at the triangle ABC. The magnitude of vector P is equal to magnitude of vector A into cos theta. This magnitude of vector P is known as projection of vector A onto line L. The direction of the projection vector depends upon the value of cos theta. Since value of cos 0 is 1, projection vector of vector A is a vector itself for theta equal to 0. Next, if value of theta varies between 0 and 90 degrees, then the direction of the projection vector P is same as the direction of line L. This is because the value of cos theta is positive for all the values of theta between 0 and 90 degrees. If the value of theta is 90 degrees, then projection vector of vector A is a 0 vector as value of cos 90 degrees is 0. Since cos theta is negative for values of theta between 90 and 180 degrees, the direction of the projection vector P is opposite in direction to line L. Now for theta equal to 180 degrees, cos theta is minus 1 and the projection of vector A is its negative vector. Similarly, value of cos theta is negative for all the values of theta between 180 and 270 degrees. So, the direction of the projection vector P is opposite to line L. Next, for theta equal to 270 degrees, projection vector of vector A is a 0 vector as value of cos 270 degrees is 0. Since cos theta is positive for values of theta between 270 and 360 degrees, the direction of the projection vector P is same as line L. Finally, for theta equal to 360 degrees, cos theta is 1 and the projection of vector A is the vector itself. In this module, you have learnt that projection vector of vector A on a line L is the vector obtained by dropping a perpendicular line from the terminal point of vector A onto line L. Also, magnitude of this projection vector is called as projection of a vector A on a line L. If theta is 0 degrees, then vector itself represents its projection vector. If theta varies between 0 and 90 degrees, then direction of projection vector is same as directed line. If theta is equal to 90 degrees, then projection vector of a vector is a 0 vector. If theta varies between 90 and 180 degrees, then direction of projection vector is opposite to directed line. If theta is equal to 180 degrees, then projection vector of a vector is its opposite vector. If theta varies between 180 and 270 degrees, then projection vector of a vector is opposite to the directed line. If theta is 270 degrees, then projection vector of a vector is a zero vector. If theta varies between 270 and 360 degrees, then direction of projection vector is same as the directed line. If theta is equal to 360 degrees, then vector itself represents its projection vector.